Okay, we're starting off with lesson number 1 here. So before we get into it, a couple things that I want to mention. Basically how it's going to work, every single day you're going to have a lesson that you need to complete. All of those will be video recorded for you to watch and follow along, make notes, whatever you need to do to make sure you understand the content. After that, there's going to be some homework questions that are assigned. To every single one of those homework questions, we have gone ahead and shown you step by step with another video on how to do every single one of those questions. So when you are done, or if you have any questions about it, you definitely want to go to that video first and see how we did it in order to make sure you're on the right track. After that, you're going to conclude every day with a quiz. Each one of these quizzes is going to be marked. Each one is open booked, so you can use your notes. And to make everything a little better, you are going to have multiple attempts on this quiz. You're going to have 2 shots at this quiz, and we're only going to take your high score. So that means if you do the quiz the first time and you get a 72, you're thinking, I don't know if I like that. No problem. Go ahead, try it again. And if you get an 80, great, we'll take the 80. And if you end up getting a 65 the next time, we'll keep your 72. So it's a really good opportunity for you to do great. You just got to make sure you put the time in to do the things that we're asking you to do. So for lesson number 1, there's really 4 things we're going to be looking at here. The first thing is how to simplify and looking at things like the distributive property. After that, we're going to look at solving for variables, some cross multiplication, and then finally finish off with y equals mx plus b. I want to stress that every lesson is just that. It's a very small lesson. Really, the way you get better at this is by doing the math and taking a look at the solutions video that is provided there, because we look at step by step on how to do everything for you. Okay, so let's take a look at simplifying and the distributive property and all that kind of stuff. So let's start off with a nice easy one here. So we have 3x minus 2x plus 7x. Whenever you are simplifying things, you have to make sure that they're what we call like terms. And when we say collect like terms, that's an expression you're going to hear me refer to a lot. You have to make sure that basically they have the same variable here. So here, we're in good shape. Everything has an x attached to it, which means these things are alike. And we can kind of work with them that way. So since they all have an x attached to them, what we want to do is we want to look at the numbers in front. Now we call those things our coefficients. And those are just numbers that are multiplying with that variable, that x. So for our first one there, it's 3x. That just means 3 times x. So what we do when we are collecting our like terms is we are only concerned with the numbers in front. So here, the number in front is 3. Here, the number in front is negative 2. You always look at that sign in front. And here, the number is positive 7. So if I ask you to simplify this, basically what we're doing is how many x's do we have? Well, we have 3x minus 2x plus 7x. What you'll do is you'll do 3 minus 2 plus 7. Remember, we're only concerned with the numbers in front. We're only concerned with those coefficients. 3 minus 2 plus 7, so 3 minus 2 is 1, plus 7 is 8. So we end up with 8. But we have to make sure we attach that x to it on the back end. Okay, let's do another one. Let's say we have 7a squared minus 6a plus 2a squared minus 3. Okay, so here we have a couple of things that we need to take account of. The first thing is we have a, but we also have a squared, and then we have just a number. So we have some different things going on. Now, in the last one, everything was an x, so it was very nice and easy, but you can only work with, for instance, a squared only works with a squared. You can't mix an a squared and an a. So what we're going to do is first we'll focus on our a squareds. So here we have 7a squared, and then the only other a squared we have here is the plus 2a squared. So if we have 7a squared plus 2a squared, we end up with 9a squared. Then we have minus 6a is our next thing. But here there's no other minus 6a's or any other a terms that we can mess with. In fact, this minus 3 we can't really do too much with either. So this minus 6a, well, it's not going to be changed at all because there's nothing to change it. And this minus 3, there's no other numbers in order to change it. Okay, and we'll try maybe one more. Okay, so first thing we'll do is we will start off with our very first term here, which is our x. And remember, we can only mess with other x's. So here we have 4x, and the only other term that has an x in it is this minus 3x. So we're going to take 4 minus 3, and we end up with 1x. If you ever have a situation where you have 1x, you don't ever really want to write that 1. We can just write x. It means the exact same thing as 1, because 1 times x is just x. The next thing we'll look at is our x squared. So we have 16x squared. Now we have positive 16 over here, and we have negative 4 over here. So 16 minus 4 is going to give us 12. So we have plus 12x squared. Remember, we have to put that x squared on the back. And the last thing here is we have our numbers, plus 7 and minus 3. So that's easy. We've been adding up numbers since we first started school. So 7 minus 3 is going to be positive 4. And we're good. Next thing we're going to look at is our distributive property. So with our distributive property, we're going to look at an easy example to start. We have 2 times x plus 6. So distributive property means we have a number attached to something in brackets. So here we have a number multiplying with whatever's going on inside our brackets. So what we do is we say we distribute that number in. So what that means is that 2 is going to go ahead and it's going to multiply with the x, and then it's going to multiply with this, the 6. And if there were more terms, it would multiply with every single thing inside that bracket. So here, 2 times x. Well, what actually happens when you multiply a variable with a number is it always multiplies with the number in front of the variable. But here, there is no number in front of the variable, except there's always that imaginary little 1 there that we kind of don't really like to write. So what happens here is that 2 multiplies with the number in front. So 2 times 1, that's going to give us 2x. And then plus 2 times 6, that gives us 12. Okay, let's look at a little more of a complicated one. Okay, next thing we're going to do, we're going to use our distributive property again. So we're going to distribute it in there, and in there, and in there. And remember, numbers can only multiply with other numbers. So here we have 3 times 2x squared. And what that's going to give us, we're going to have that 3 times the 2. And then we'll just write that x squared after. Remember, the number only multiplies with the other number. So 3 times 2, 6x squared, plus 3 times 4. That's going to give us 12x, and then 6 times 3 is going to give us 18. So keep that in mind. Remember, numbers only multiply with other numbers. So what happens then if we have something like here, what we're going to do is we have our number 2 and our variable y. So what's going to happen is the number is always going to multiply with the number, and the variable is going to multiply with the variable. So I'll show you how that works. So what we have here is we have this 2y being multiplied by y squared. So the 2 is going to multiply with the number. Remember, there's an imaginary 1 there. So we're going to end up with 2 times 1, which is 2. And then the y's are going to multiply together. Y times y squared ends up being y cubed, because we just added another y. The next thing, that 2y is going to multiply with the 4y. And then we're going to have 2 times the 4. Remember, you want to do the multiplication of the coefficients first. And then we have our y times our y, which is y squared. And the last part, 2 times 2. 2 times 2 is 4, and then the y doesn't multiply with anything, so we just kick it on the back. Perfect. And that's a little bit of simplification and distributive property and all that kind of stuff. Now we can move on to actually solving for our variables. So let's take a look at an example here. Okay, so when we are solving for variables, what we want to pay attention to is isolation. So the key here is we always want to isolate our variable. And what that means is we want to get it to one side, and then we want to have every single other number on the other side. And what will help us do that is moving things across the equal sign. So for instance, here we have a 7x. That's our variable. We want to isolate that. But then we have a minus 3 over here, right? This minus 3. We want to move that over to the other side of the equal sign. And what always happens when you move something across the other side of the equal sign, we must switch signs. So that minus 3 is actually going to become positive 3. So I'll show you how that looks. 7x, this minus 3 is now on the other side, so we can't write it on the left side anymore, equals 4, and then this minus 3 became positive 3. Now what we'll do is we'll just collect our like terms like we did before. 7x equals 4 plus 3 is 7. And now what we want to do is we want to get x by itself. So what's happening is 7 times x. So we'll always need to do the opposite operation. So what we'll do is we'll divide this side by 7. And what you do to the left side, you must do to the right side. So we will divide this side by 7. Those 7s are going to cross out. You're just left with x on this side. And on this side, 7 divided by 7, it's just going to give you the number 1. Okay, perfect. We'll go to the next one here. Next one, we have 3y plus 7 equals 5y minus 1. So now we have a couple of things happening. We don't just have variables on the left or the right, we have variables on the left and the right. So we can pick and choose. Do we want to move all our variables to the right side or the left side? And the best part is it doesn't matter. Whatever you choose, you will end up with the right answer as long as you follow the right steps. So I'm just going to decide to move all my variables to the left and all my numbers to the right. So what I'm going to do is I'm going to move that 7 over there, and I'll move that 5y over there. So I'll end up on the left side with 3y, and now I can't write that 7 because it's moved over. That 5y, remember it crossed over the equal sign, so that positive 5y is going to become negative 5y. And on the other side, we have that negative 1 is still there. And now that positive 7 became minus 7. Now what we'll do is we'll do the same thing we've done before, collect our like terms. 3y minus 5y, remember you're only looking at the numbers in front. 3 minus 5 is negative 2, and then just put that y on the end, equals negative 1 minus 7. Negative 1 minus 7 is negative 8. Now what we need to do, same thing we did in the last step, we just take the coefficient and we divide. So this side, to get y by itself, we divide by negative 2. Those two things are going to cancel out. And on this side, we must divide by negative 2 as well. So we end up with y equals negative 8 divided by negative 2, which is 4. Okay, let's take a look at one more, and this one might be a little more challenging. Actually, I'm going to switch that up. Okay. So we have a bunch of things going on here, and we got to make sure we follow our order of operations. Now, hopefully you remember something about BEDMAS, and that's brackets, exponents, multiplication, division, addition, subtraction. It's just the order of operations. We always want to do our brackets first, but here, is there anything we can do in the brackets? Can we add x plus 6? Can we make that any simpler? No, we can't, because we can't add an x plus a 6, because that 6 does not have an x in it. And same story with the 3x minus 2. There's nothing we can do there, so the next thing we need to do is our distributive property. So what we're going to do is we're going to distribute that 4 in over here. So we have 4 times x is going to give us 4x, plus 4 times 6 is going to give us 24. On the other side, it's equals 7. And then we have a minus sign. So what we actually have here is we actually have to distribute that minus sign in to everything in the brackets, because that is what's in front, and we always need to distribute in, because there's really like this little imaginary minus 1 there. So what this actually ends up doing is it just ends up flipping the sign of everything that's in our brackets. So this positive 3x is now going to become minus 3x, and this minus 2 or negative 2 is going to become positive 2. Now what we'll do is we'll just clean up some stuff. So why don't we put all our variables on the left and all our numbers on the right. So it's going to be 4x. That minus 3x is going to become positive 3x. equals, and on this side we're going to have the 7, we still have our plus 2, and now we're going to have minus 24. So on the left side we have 4x plus 3x, that's going to give us 7x. On this side we have 7 plus 2, which is 9, minus 24. So if you need to use your calculator, go ahead and do it. It's going to give us negative 15. So now do the exact same thing we did before, divide by 7, and you're going to get x equals negative 15 divided by 7. You can choose to leave it like that, or if you'd prefer, you can get out your calculator and look for the decimal value, and that's going to give you a decimal of negative 2.14. Perfect. So that is the distributive property. So we've looked at solving some equations. We should be good there. The other situation you might run into today is if I gave you a full equation. So if I gave you something like 3x plus 14 equals 3y minus 2x squared. And I said, okay, what we're going to do is I want you to solve for y if x equals 2. So can we do that? So what we're doing here is we're actually going to take that number that I've given you for x and we're going to plug it into the equation. Now whenever you insert this number, x equals 2, into our equation, we have to make sure we are following some steps. So 3, and now we have x, but now I know my x equals 2. So instead of writing x, what I'm going to do is I'm just going to put in brackets my 2 there. Plus 14 equals 3y. I have no idea what y is. That's what we're trying to solve. Minus 2, and then I have an x there, so I'm going to put in brackets my 2 squared. So now what I'll do is I can clean this up a little bit. So why don't I go 3 times 2, that's going to give me 6, plus 14 equals 3y, and then here we have a whole bunch of stuff going on. My recommendation is always just put that in your calculator right away and let your calculator do it for you. If you don't want to do that, what you're going to do is you're going to do our exponents first. So we're going to go 2 squared, which is going to give us 4, times 2, which is going to give us 8. I would just recommend putting 2 times 2 squared into your calculator, and that's also going to give you 8. Now what we have to do is we have to just isolate for y, so I'm just going to slide that over, and we get 6 plus 14. That negative 8 is going to become positive 8, and we get 3y. 6 plus 14 plus 8 is going to give you 28 equals 3y. Just divide both sides by 3, divide by 3. And you're going to get 28 divided by 3, which is a perfectly fine response. You can leave it as a decimal and get 9.3 equals y. Either is acceptable. Okay, perfect. Next thing we're going to look at is cross multiplication. Cross multiplication is a very handy thing. It's going to help you a lot, especially in the first 5 days of this course. And basically what you're looking at for cross multiplication is what we like to call a fraction sandwich. If you have a fraction sandwich, it means you have a fraction on the left, a fraction on the right, and then an equal sign in the middle. So this is how it would look. If we had something like x over 6 equals y over 7. This is a fraction sandwich. Fraction on the left, fraction on the right, and then our equal sign. If you have this, you can follow some very unique rules that is going to make your life a whole lot easier. So here are the rules. You can multiply diagonally across the equal sign. If you remember this, it will help you in so many ways moving forward in math. So what I mean by that is, let me show you right now. So if I had something like x over 7 equals 6 over 12. Okay? So what this means is, since I have a fraction sandwich, I have a fraction on the left, fraction on the right, equal sign in the middle, I am free to use this rule. Multiply diagonally across the equal sign. If I wanted to isolate for x, what I can do is I can multiply diagonally. So I'm going to take that 7 and I will multiply it up. And what that leaves me with is now x, there's no more over 7 because that 7 has now been multiplied up, equals 6 times 7 over 12. So that's going to be x equals 42 over 12. And we can reduce that or put in a decimal straight away. That gives you 3.5. Okay, let's take a look at another example. So if I had 14 over 28 equals 6 over x. Well, this one's a little bit harder because the x is on the bottom. So we need to figure out a way to make that x get to the top and then get isolated. So remember, we can always multiply diagonally across the equal sign. So what I'm going to do is I'm going to multiply that x diagonally across the equal sign, and then I can also multiply this 28 diagonally across the equal sign. So what I've done there is what we call cross multiplication. So we're going to have 14 times x, that's going to be 14x, equals 6 times 28. And 6 times 28 is 168. So I've really cleaned that up in just one very, very quick move. Now, what I need to do, like always, I need to get the x by itself, divide left side by 14, divide the right side by 14. Those two things are going to cancel out. And when you do that, you're going to get a nice even number of x equals 12. Now, the best part about cross multiplication is you can make it happen with anything. So if I had something like y divided by 6 equals 3. Well, you're looking at this and you're like, well, it's not quite a fraction sandwich. It's not quite cross multiplication. I can make it cross multiplication. So what I need to do there is I can turn this into a fraction. How do I do that? I add a denominator. So I can make up a denominator. And the denominator you always use is divided by 1 because that doesn't change the actual number itself. So I have y over 6 equals 3 divided by 1, and now I can use my cross multiplication. So I'll just multiply that up, and we get y equals 3 times 6, which is 18 divided by 1, which is just 18. So cross multiplication is a very, very handy tool. Okay, keep that in mind. It's a good shortcut. You don't need to use it, but I strongly recommend going for it if you can. Okay, and now the last thing we're going to talk about before you're off doing your homework is y equals mx plus b. This is the equation for a linear relationship, which is just a very, very fancy way of saying a straight line. So last year, you learned all about straight lines, and you probably remember some graphs that looked like this, and you probably even remember some words like y-intercept, just where that graph crossed that y-axis, and it would be that point right there. Now, we could draw our graphs, or we could represent them using y equals mx plus b. And that y-intercept on the graph is there, but in my equation is this b value. So for instance, if I had the equation y equals 3x plus 2, well, that 2 is my y-intercept in this sense, and that means it would be that number right there, just where that graph crosses the axis. The other thing in this equation that we always want to pay attention to is this value, which is our m value. It means slope. It's how fast this thing is either rising or falling. And we have a very easy way to calculate it. We can use our rise over our run. So what that means for us is if I have this little graph here, and I have this point, and I have this point, and this point is 1, 1, and this point is 3, 3. What I can do is if I asked you what is the slope of this line, you can calculate the rise over the run. So what that means is I'm going to take this first point here and I'm going to say, okay, how far up do I go? So what is my rise? So I'm going to go up. And how far did I go up? I went from 1 to 3, so I moved up 2 steps. And how far over did I go? I went from 1 to 3, and I also went 2 steps. So my slope, which we write using the letter m, is going to equal 2, which is my rise, over my run, which is 2, and that gives me a rise over run of 1. And that also works for graphs that are falling. So if I had something like this. So if this was a point, maybe -3 and -1. And then I got a point over here where maybe it's this point here. And I had 2 and I had -1. Well, I can do the exact same thing. So if this is one point and this is another point, I can still look at my rise over run. So to show you, if I start here, my rise is now no longer rising, it's actually falling. So how far did I step down? Well, I went from 3 up top here all the way down to -1. So 3 down to -1 means I moved down 4. So I went -4. So my M equals my rise over run. So my rise, we just said it moved down 4 steps, we get -4. Then we have to go this way. So we stepped over from -1 to 2. So how big of a jump is that? -1 to 2 is going to be a jump of 3. So my run is 3. So my slope then is -4 divided by 3, or -1.33. Okay. These are how we express our linear relationships. They're always going to be in the form y equals mx plus b, where m is our slope, b is our y-intercept. We'll be studying this in a full unit for the most part, which will take us a couple of days in this course, and kind of reviewing some of those concepts and problem solving with this. But keep this information in mind, you will see some of it today. So now, what you need to do is you need to go start your homework, take a look at those solution videos. They are extremely helpful. Make sure you are doing those questions. And what you really need to do, every day, you need to take at least one attempt on your quizzes. If you don't, you are going to have very big issues in this course. They are not difficult quizzes. Most of them are multiple choice or matching. We're not asking you to do a lot. We are asking you to get these things done. This is what is going to shape your grade. Make sure you take the time and do them well. All right, let's get started.